Hello and welcome to the last calculus series before differential equations. What am I talking about? I'm talking about calculus 3, otherwise known as vector calculus, otherwise known as my playground. I won't get that cocky, but let's just hop into it. So Calc 3, we're working a lot in 3D space. We're actually always working in 3D space, or 4D space, or 5D space. Higher dimensional calculus, you could think of it as well. And this is very fun to me, and I hope you guys have a lot of fun with this too. But first we need to talk about the 3D coordinate system. So we have our 3D space, and this plane down here is what we're kind of used to. This is just like the regular stuff that we've seen where we have a 2D graph. And so to make this more clear, this is x, that's y. But now we have this thing sticking out here. This is z, or z, depending where you're from. I'm supposed to say z, but I prefer z. And so there's two ways we can represent where we are in this space. Well, we could say we have a point, and it just has coordinates x, y, z, which are pretty easy. You just, if you were to bring this down, you would have your coordinates x, y here, but now we're sticking out by a value of z. But there is a tad bit more complicated version of this, although once you get used to it, it's not that hard to wrap your head around. And this coordinate system is very well used for spheres and things, which are also very good to know because when we get into things like the divergence theorem, we want to know about our applications like point charges and the Maxwell's equations. So back in regular old stuff, we had another system, polar coordinates, where we would have a value theta. And this value theta still exists. It's still the same thing. It's coming off of the x and it's in the xy plane. But now we have another angle coming off of the z-axis, and we call that angle phi. Now, a lot of people have probably seen this angle before, and so both of these angles can span from 0 to 2 pi. But now that we understand 3D space, let's talk about some 3D shapes. So first shape we have is a sphere. They're kind of hard to draw. Hard to draw 3D things in a 2D space, but you guys can imagine we have our axes coming through here, you know, one also coming through there. And so this is our sphere. Spheres are represented by the equation x squared plus y squared plus z squared equals r squared. So very similar to 2D space, we're just adding another variable. And a lot of you might be wondering, why is it not x squared plus y squared equals r squared? Well, that brings us to our next shape. That shape is the cylinder. where x squared plus y squared equals r squared. And you might notice we have these caps here on the cylinder. That's just the span of z. So we could say that this is z at the top and z at the bottom. If we didn't have parameters for z, say z was in between two values, z is greater than or equal to and a and less than or equal to b, this would be b, this would be a. Yeah. If we didn't have these parameters, it would just be an infinite cylinder, which we don't see a lot, but yeah. And the last thing we can have is a cone. The cone looks a bit like this, and we have our coordinates, of course, our graph coming through like that. It's not very well drawn, but you get the idea. And this is just x squared plus y squared equals z squared. And so where this comes from is the x squared plus y squared basically make this circle that we see here that comes down onto the x and y areas. And the z squared is, you can think of that as almost like a triangle, because we have our right angle triangle coming off of these projections down. So that's 3D space, that's 3D coordinates. I hope this video helped if you were struggling with this, or I hope it gave you a good introduction to the rest of the series. Thanks for watching.